How do you identify the x and y intercepts of a linear equation? Our first vocab word for this lesson is standard form. Standard form is ax plus by equals c. On the next slide, we'll get into more about what those represent. So I'm just going to write down that equation for now. Our x-intercept is where a line crosses the x-axis, and the y-intercept is where a line crosses the y-axis. Here are our standard form rules. These are very important for all standard form equations. This is something you're going to need to memorize over time. So first of all, standard form, just like we wrote on the last slide, is ax plus by equals c. It is really important that standard form is written in this specific order. X and y are on the left, and then a c, or an integer, which you'll hear about in a second, is always on the right. X and y have to be on the same side. Our rules for a is that it has to be a positive integer. So it could be 0, 1, 2, 3, and so on. It cannot have any negatives, decimals, fractions, any of those things. It has to be an integer, and it has to be positive. B and C are integers, but they don't have to be positive. So you'll notice here in the examples, there are negatives included. There are no negatives for A. B and C can have negatives. No fractions are allowed. No decimals are allowed. Let's look at some standard form examples and figure out whether or not they truly are in standard form. So this first one, negative 15x plus 4y equals 8. A cannot be negative, so this one is not in standard form. So no, A can't be negative. The second one has x and y on opposite sides. So no, x and y must be on the same side. Third one, x and y are on the same side. A is positive, B and C are integers, and there are no fractions, so that one is yes. Fourth one is hard. There's following all the rules except x and y are on the right, and the negative 23 is on the left. So technically it's no, because it has to go in this order. Fifth one, we've got a fraction, which is not allowed. So no, there's a fraction. And last, 6x minus 3y equals 11. A is positive. X and y are on the same left side. We have no fractions, no decimals, and B and C are integers, so that one would be yes. All the rules are followed. Why learn about standard form? So that you may graph using the x and y intercepts. So that is what we're going to use standard form for today. We're going to use it to graph our intercepts. Here is how we do that. Let's say I make a random line on this graph. We'll have it go from right here to right here. If I want to look at where my line crosses the x-axis, it's right about here, which would be the coordinate point 0, 1, 2, 3, 4. And if I want to look where it's crossing my y-axis, it's right here, which would be negative 2, 0. You'll notice something in common about both of these coordinate points. They both have a 0 in them. One of the zeros is in the x spot, one of the zeros is in the y spot. That is because when a line crosses an axis, it's always at 0 something or something 0. you'll see we've got this table already set up for you in the upper right-hand corner. We've put these zeros in there for you already, because I know if I want to find the intercepts, 0 is going to be in both of my coordinate points. So the way that I figure out my other points is by plugging those numbers into the equation. So first thing, I'm going to take this 0 and plug it in for x in my equation. So 3 times 0 minus y equals 6. Draw my train tracks. 3 times 0 is 0, so I'm just going to x that out. Bring down your negative y equals 6. Now you might be thinking we're done there, but our problem is y cannot be negative. When you solve for a variable and you just have the variable left, it cannot be negative. The way you get rid of it is if we have a variable without a number in front, that a 1 can go there. The way you get rid of the negative 1 is by dividing both sides by negative 1. So y equals negative 6. I'm going to put that in right here. So I've got one of my 2 coordinate points. Now I'm going to take this 0 and plug that in for y. So 3x minus 0 equals 6. Draw my train tracks. This 0, we don't need that in the equation. 3x equals 6. Break up my couple. X equals 2. Now I've got 2 coordinate points. So let's erase this line we made earlier. I'm going to move my graph up over here so I have a little more space. Alright, so let's graph these 2 coordinate points. 0, negative 6. 1, 2, 3, 4, 5, 6. My smart board's a little off, so it's not exactly on the dot, but that's okay. And 2, 0. I draw my line. Now if you look at my line, my x-intercept, so where my line crossed the x-intercept, was at the number 2, which is right here under the x column. My y-intercept, which was right here, is at negative 6, which is right there. Let's try that process again. Now we have a new equation, 2x plus 5y equals 10. Again, we have this table with the zeros, because remember, if a line crosses the axes, 0 is going to be in the coordinate, either for the x or the y. Let's take the 0 and plug it in for x. 2 times 0 plus 5y equals 10. 2 times 0 is 0, so I'll x that out. Draw my train tracks, bring down the 5y equals 10. Break up my couple. I'm left with y equals 2. Put that over here. That's going to be one of my intercepts. Then I'll plug 0 in for y. 2x plus 5 times 0 equals 10. This makes 0, so that's gone. 2x equals 10. Break up my couple. X equals 5. There's my other intercept. Bring my coordinate grid up. I can graph both of those. 0, 2 is right here. 5, 0, 1, 2, 3, 4, 5. Connect it with a line. Now looking at my table before I even look at my graph, my y-intercept should be 2. Let's check if it is. Yep, it crosses the y-axis at 2. My x-intercept should be 5. Let's see. Yep, my x-intercept, my line crosses the y at 5.
Oliver Castor, please come to the office. Oliver Castor, please come to the office.
All right, your homework for this lesson is a worksheet. You're going to practice graphing using the intercepts.